Hello students, welcome to the next lecture on the complex analysis. Today we will discuss about Schwarz Lemma. Myself Dr. Harish Garg. You can simply follow my YouTube channel. There is a playlist of the CSIR net UGC gate. We can see there is a PY questions of the topic wise. The last lecture was on the identity theorem. You can simply follow this lecture before watching this Schwarz Lemma. I can continue the results from this identity theorem. Apart from that, you can also see there are many other lectures, PY questions, with the help of the shortcut tricks on the topic wise as well as the complete year wise also available in this PY playlist. So the objective is we will cover all those questions from the gate examinations as well as the CSIR net related to this topic from these years. So what is the brief theory about that and what are the various shortcut tricks? If you have the unit open disk D and f is my analytic function with this important property, that f of 0 is by 0, then this Schwarz lemma said if f of z is less than of the z and the derivative is my bounded at the origin, or if the equality is holding at the both of side, then f of z is my linear function with the property mod of a, the absolute value of the a is 1. Another way is if you have a function f of z, if you prove that the function is analytic, function is bounded and 0 is the root of the function f of z. You can read this line as such also. Or if you already have a function, then check whether f of 0 is 0 or not. Now since if these three properties satisfied, then you can say the derivative at the point of this 0 must be less than 1 and the function is less than equal to z for all z is not equal to 0. Now since in this case it is given that 0 is the single root of here, that's a simple root of f of z. What will happen if it has a multiple root? Like if f of 0 is 0, f dash is a 0 is 0. What does it mean? 0 is my double root. So whenever if I consider this is the mth root, then we can extend this result, these two results, like here is a first derivative, we can extend them to be the mth derivative. If mth derivative should be less than of the m factorial and f of z should be less than of z raised to power m. The most important text is the PYQ theorem. This result is applicable only if you have f of a is given and your target is to find f dash of a. Then you always apply this result. On the other hand, if f of 0 is given to you and your target is to find f of a, then you always apply this rule. So based on these 1 and based on these 3, that is a 1, 2 and 3, based on these 3 simple tips, I can solve all those PY questions within a couple of seconds. So before I start with PY questions, you can simply scan and join my WhatsApp group for the various discussion. So let's start with this question. Now look at that. F of 0 is given to you and your target is to find here. So what is the rule is? If you have this value, I can always use this result 1 minus a square. Now look at that. In this case 0 is given to you, so I can find the bound of the 0. So it is a 1 minus, what is f of 0 is half, so 1 over 4, 1 minus 0, it's my 3 over 4. So clearly say first answer is correct option. Again in this case a is my half is given to you, I can find the bounds on half. So what is that? It is less than of 1 minus 0 a square, so it's a 1 over 4, it is my 4 over 3. So clearly says second option is also correct. Third option is a combination of the first and second, it's also correct option. Last option is incorrect because f of 0 is 0 satisfied, but f of half is not equal to half because it's a 0. So therefore A, B, C are my correct answer. Look at this next one. F of 0 is again given to you and your target is to find the values at f of 0. So again I can apply this shortcut formula. So which is less than of, what is f of 0 is 0, 1 minus 0, that is a less than equal to 1. Again f of half is given to you, so I can apply this property again. So it is f of half is 0, 1 minus 4, so it's a 4 over 3. So this also satisfied. Third option is the combination of the first and second, also satisfied. Again this option is cancelled out because f of half is not equal to f of half. So my right answer is A, B and C are my right answer. You can also read like this way. This means f is my identity mapping. So that is not correct. Look at this another question. Again f of 0 is given to you and your target is to find the bound on this. So firstly I can check the bound, which is less than of f of 0 is 0 and 1 minus 0, which is less than equal to 1. So that means I can check my property of this. Now remember, they are talking about the property, whether can you find any of the function which satisfied f of 0 is 0 and derivative should be less than. So clearly say it's satisfied because half is less than equal to 1, satisfied. Moreover, you can think about any of the function whose derivative will be half and function is a 0. You can think about here, it satisfied this property, clearly say this is also satisfied. You can see it's a half dash. What is that? It's a secant 30 degree. What is the secant 30 degrees? 2 by root 3. Clearly say this number is my greater than 1. It not satisfied my this property. This option is cancelled. Fine. Now look at this one. So it is a 1 by 3, but it is not given as whether 1 over 3 is given to you. It is not given. So but f of 0 is given. Then I can apply this property, f of 0 plus 1 plus f0 into this. So what is that? What is my f of 1 over 3? F of 0 is my 0 plus 1 over 3. This is 0. So it should be less than of 1 over 3. Fine. Now look at that, which option is not satisfied. If I look about here, is it 1 over 4 is less than 1 over 3? Yes. Is 1 over 2 is less than of 1 over 3? Not satisfied. Right answers are A and B are my correct answers. Remember, whenever the function 0 is given to you, whenever f of 0 is given to you and your target is to find at some another point, always apply this formula. Whenever f of A is given to you and your target is to find f dash A, always apply this formula. Look at this one. Again, f of 0 is 0 given to you. Your target is to find the derivative value. So what is that? F dash of 0 is less than of 1 minus f0 square over 1 minus 0 square, which is 1 minus 0 over 1 minus. So what does it mean? F dash of 0 is less than or equal to 1. So look at that, which option is, this is strictly equal to 1, but is it true? It may be true. Okay, look at that, this option is it true? This option may be true. No, because this option may be true, this is not true. Why? Because he said it's strictly less than 1. He said upper bound is half. Clearly say, if I simply take f of z is my say 0.7 z, it satisfies this property f of 0. So what is the derivative of this? 0.7. So clearly say f dash of 0, it is my 0.7, which is not less than of half. So this option is cancelled. Also this option is again cancelled by using this property because it's a less than or equal to 1. It's only equality. So that's option cancelled. Now what is the f of, again because f of 0 is given to you, so I can apply this again, this property is for f of half. So what is that? F of half is f of 0 plus this over 1 plus f of 0 into mod of z. So f of 0 is 0, this is half, this is 0 here, so it is less than of half. So f of half is my here, upper bound is my half, but he said it's a 0.25, it is my 0.5. So this is satisfied, but it is a 0.25 not satisfied. So right answer is only B is my correct answer for this problem. Look at this another one. F of 0 is given to you, f dash. Now Okay, now they ask there exist, not always. He said there exist. Can you find a function? Okay, we can firstly find whether. Now you can see the next part. It is here f of 0 and f. So there exist. So there are firstly 0 is point given to you and the derivative is also given. So can I check the bound on this firstly? It is 1 minus f of 0, 1 minus 0. It should be less than of 1. But he said 2. It means there does not exist any of the f which satisfy these two properties. So first option definitely cancel out. Look at this one. It's a 3 over 4. But it is not 3 over 4. It is 3 over 4. It is not 3 over 4. It is 1 over 2, but it is not 1 over 2. So you can't apply this formula. Now, again, f of 0 is not given to you for this B, C and D. So again, you can't apply this formula because it's f of 0 and here. Then how you can approach them? So very simple, you can apply the curve fitting. So like here, for this case, if I assume f is my az plus b, why I consider only the linear equation? Because it is given only as the first and the original function. So what is the f of 3 by 4? So that clearly says it is 3 over 4 is 3 over 4 a plus b. And what is my f dash? F dash is my a. So from this case, you can see f of 2 by 3, that implies a is my 3 over 4. Once I substitute here, what is my b? It's 3 over 4 minus 9 over 16. So it is my 3 over 16. So what is my function? Function is my a, 3 over 4z plus 3 over 16. Fine. So it means there exists. Yes, you are able to find there exists. So that's the correct option. Look at this one. F of 3 by 4. Again, I can apply this formula here. Then f of 3 by 4 is again 3 by 4. Is 3 by 4 a plus b, and f dash is my, so a will be my minus 3 over 4. Once a is my minus 3 over 4, can you find the b from here? It is 3 over 4 minus minus plus 9 over 16. So that's again a finite answer. So it's 4, 12 plus 9. So you can get a as my finite, b as finite. So yes, you can get as this is my correct answer. Now look at this another one. Again, I can apply this one. So f of half is a by 2 plus b, and from this case I can say a is my 1. Once a is my 1, b will be my, is a 1, is a minus 1. So the function will be my z minus 1. But there is existence of the function, but clearly say what is my domain is. So can you say what is the f of 0 minus 1? Is the f is a function from domain d to d, but minus 1 does not belong to it because it's an open interval. So this option is cancelled. In this case, if you look over here, what is the f of 0? Is a 3 over 16, which is the part of this domain. So clearly say again this option is satisfied. So the right answers are my B and C are the correct answer. Okay, look at this another one. It's a 2020. F of 0 is given to be iota, and f of mod of f is my 1. Fine. Okay, can you find the absolute value? It is given to you as 1, and f of this is given to be here. What is the meaning of that? It means f of z attain, because it's a 1 and it's a 1, attain its minimum value at the point z is 0. Which things come in your mind whenever there is attain a minimum or maximum value? You can apply the minimum modulo principle. Fine. So what is the minimum modulo principle? He said the function is my constant provided the function is constant provided the function value is maximum at the point A, it must belong to the domain. What is my A in this case? Function is attained at the 0. Is this part of the domain? You can see my domain is here. It's a unit circle. So domain 0 belongs to the domain. Yes, it means function is my constant. So what is the function? If function is my constant and it attains at here, so what this means? F of z is my iota. So what is the f of half? F of half is also my iota is the right answer of this problem. Look at this another one. F of 0 is given to you as a 0. F of dash is 0 is given to be here. What does it mean? 0 is my double root. Fine. Once is a double root, we can say f of z is less than of z of 2. Now, what is the possible value of this? So clearly says f of half is less than of 1 over 4. Now look at the option. What is the possible value? Equality 1 by 4 possible. Minus 1 by 4 is again satisfied. Is it less than satisfied? Clearly say it is not satisfied because it's a 0.33. It is 0.25, not satisfied. Minus 1 by 3 mode, again it's a plus 1 by 3, it's a 0.25, again not satisfied. Right answers are A and B are my right answer. Also, you can see if you apply this rule, f of z is less than of f of 0 plus over 1 plus f0 and z, because f0 is given to you. So now you can see f of 0 is my 0, z will be my here and this. So but this value is less than of, but here this is a double root, so you can't apply this formula as such. Fine. So that's why this option is not correct option. Look at this another one. D is a unit open disk. Here G is my holomorphic, so G is my analytic is given to you. G of 0 is my 0. Fine. Now you can see G dash. Can you find the G dash, which is 1 minus G of square and 1 minus 0 square, which is 1 minus 0 over 1, which is 1, but he said greater than 1. This option is cancelled out. Now it's a half. Again G of half, so I can apply this again is f of 0, G of 0 plus this over 1 plus G of 0 and this. So what is that? G of 0 is 0, this is my mod z and this is 1. So it means G of half will be less than of half. Fine. Therefore this option is satisfied. Now you have to check whether H is my holomorphic or not. It means H is my analytic or not. And second property. How you can think about that? That's very simple. You can see G is my analytic function. So if G is my analytic function, then definitely this is also the analytic function for all z which is in the domain apart from the 0. So it means I have to check only at z is equal to 0. If I prove z is this function, that means this is my H. H is my analytic for all those z, but he said all those. Now I can check about the properties of the 0 at this. So it is my here. Fine. So what is the limit of this divided by here? Fine. G of 0 is 0, so it's a 0 by 0. So I can apply the derivative of this. So what is that? It's a G dash 0, and which is to be here. What is the meaning of that? It means H is my analytic at z is equal to 0. Also it is also analytic D minus, so it means H is my analytic for all z in the domain. So this option is correct option. Now how you can prove this? So again I can start from here. What is my H of z, which is G of z over this. What is a G of z? It's an analytic function, so the open domain is my here, which is less than of this case. Fine. But okay, another is because H is my analytic function, so I can say this function is less than of this. Fine. Then no, this is my target, so I can say G over this is my less than of this. Fine. This is less than of here, and this value is my unit open disk. It should be less than or equal to 1. So what does it means? H of z is less than equal to 1 for all z in the domain. So what is h of d is my satisfied. Right answers are A and B are the correct answers. Look at this another one. F is my holomorphic function on the domain D such that f is my here. Consider a function which of the following are my satisfied. Initial condition is not given to you. Fine. Now in the last question, initial condition is given to you. Then you can easily find the derivative here. But in this case, initial conditions are not given to you. So what you can think about that? Okay, firstly I can find about the f dash 0. Fine. How you can find the f dash 0? Again, I can apply the same approach. F dash 0 minus 1 minus 0 square. It is 1 minus f of, but f of 0 is unknown to you. So clearly say this 1 minus is always be less than of the 1. So what is the meaning of that? F dash 0 is always less than of the 1 is the right answer. F dash, but now it's a 0. How you can find the derivative? F is a holomorphic function. If you simply take any of the holomorphic function, any of say z scale, fine. Now what is my g? If I take this is my, clearly say this is my analytic function, fine, and fine. Now what is the of this value? It should be less than of here, clear? But I need the derivative. What is my f dash of z? It should be 2 of z. It should be 2 times of this. On this domain it should be less than or equal to 2, but he said less than of 1 is a wrong option, because there may exist a function whose derivative should be 1.5. So this option is cancelled out. Now whether g is a holomorphic function, that is, a g is analytic or not. Again you can see about that. G is my here, f is analytic, fine. What about the f is analytic? It is given. F over this is also analytic for all those z in my domain apart from the 0. Fine. Now what about the at, how you can say about, okay, again a very simple, I can simply take a function f, any of the constant function, any of the function which satisfied this property, say a, any of the function which satisfied this property constant, where a is my less than 1, I can simply take as a half. Fine. If I simply choose this function, therefore what is my g? 1 over 2z, f dash is my 0 whenever z is my non-zero and z is my 0. Now is it a whole? Clearly say this is my unbounded function. Why? Because if you take mod of g, it will be half. Now whenever z is my less than 1, it should be greater than of half. So it should be, it can never be less than of 1 because it is an unbounded function. Now how you can prove that it's a holomorphic? Okay, again, now since g is my here, what does it mean? G has a pole at z is 0. Fine. So once g has a singularity, it means g is my not holomorphic. Fine. So this option is cancelled. Fine. So this option cancel, this option cancel, only my D option is the correct answer. Look at this another one. It's a 2020. D is the open unit disk, f is mapping, f of 0 is my half, then only the possible value of f dash 0. So I can start the same formula, f dash of this 1 minus 0 square, which is 1 minus 1 over 4, that is my 3 over 4, less than of 3 over 4. So now you can check about the first option. Is it 7 by 8 is less than of this? 28 less than 24, not satisfied. Is it 5 over 6 less than of 3 over 4? 20 less than 18, not satisfied. 3 over 4 less than, fine. Is 1 is less than of the 3 over 4? Not satisfied. Right answer is only C is my correct answer. Always remember that this formula is useful whenever function value at some point is given and at the same point you need to be calculated derivative value. Okay, look at this one. F is the entire function such that this value is less than of this. Fine. Then f of this, I can consider this function is say my g. Fine. Now in order to find the values at the point 0, what is my g of 0? Fine. 0 1 0. Fine. F is my entire function, this is my here, so what is the meaning of that? G is my entire function. Again f of g is 0, and what is my g dash of z? So it is a z f dash plus f dash plus e raised to power z. So clearly say this number is my non-zero because of this term. So what does it mean? 0 is my simple root. Fine. So I can define this g as z times of this. This is my also analytic function. Fine. Now what is given to you? So according to this statement, now this function is my less than of here. Fine. G is my here, so it is my mod of z. No, yes, I can return this is g is my z times h of z is 1 plus mod of z. Fine. So now if I choose z is my non-zero, then what is my of this value? It is less than of 1 plus of this number. Fine. Now clearly say this number is 1 over this plus 1. So it should be less than of 1 plus 1 provided this number should be greater than of 1. That means h is my bounded. Fine. If h is my bounded, h is my analytic, what does means? By the Picard's theorem, it means h is my constant function. If h is my constant function, I assume this is my c. Fine. Now how you can find the c? That's also I can easily do. So what is my g of z? Is my c times z. Fine. Now I can substitute. What is that? I can substitute this value here. So that means c times z is z of f of 0 minus 1 plus e raised to power z. Can you find the value of the f of z from here? Cz plus 1 minus e raised to power z over z. C plus 1 minus e raised to power z over z. This is my f dash. Now your target is to find the first derivative and second derivative. So I think that's very easy. So I can simply do firstly, I can expand this. Okay, I can find the derivative. So what is the f dash? C will be 0. It is my z square, z times minus of this and 1 minus e raised to power z. So what is that? F dash of 0. So it's a 0. It's a 1 minus. So it's a 0 by 0 form. I can apply the L'Hopital rule. So this plus e raised to power minus z and minus e raised to power plus z divided by 2z. Again it's a 0 by 0. No, is it a 0 by 0 form? It's a 0. It's not a 0 by 0 form. Fine. Okay, because I need to find the second derivative also, I can do it little bit calculation easier. I can expand this series 1 plus z square by 2 factorial and so on divided by z. Fine. So if I open this bracket, so 1 will be cancelled out. I can take z as a common, that also cancel. It's a z over 2 factorial, z square over 3 factorial and so on. Now you can see what is my first derivative. 0 0 minus 1 over 2 factorial, 2 over 3 factorial z and so on. What is my derivative at 0? Minus 1 over 2. This option correct. This is cancelled. Now you want to find the second derivative at the point 0. What is the second derivative of this? 2 over 3 factorial. So it's a 1 over 3, but it's a negative of this. So it's a minus. minus 1 over 3 is the right answer. B and C are the correct options. Okay, look at this another one. F is given to you as, okay, whenever a function is given to you as here, plus function is my analytic or entire. Fine. Whenever this function is given to you, or in journal, if I call this is my k, where mod of k is my not equal to 1. Fine. Oh, sorry. This, whenever this condition hold, then this implies f of z is my constant. Always remember this rule. Whenever the entire function f of z is my f of kz, where mod of k is my 1, then f must be the constant. You can see what is that? This is my 1. It satisfied this property. So what is that? F is my constant is the right answer. Because it's a gate examination, only one correct option is there. Right answer is my B is the correct option. The maximum value of this, I can start from here. Fine. It will be less than or equal to 2 times plus 1. Z value will be less than of 2 times plus 1, that is my 3. Maximum value is my 3 is the right answer. Okay, f is my analytic function, f of 0 is my 0, f of 1 is my 2. So what this means? So clearly say f of z is not equal to z. Fine. So what is the mean? Can you find the curve fitting? So if I choose f is my az plus b, f of 0 0 means b is equal to 0. Fine. F of 1 2 means that is 2 is equal to a. So therefore my function is 2z. Fine. Which is non-constant. Fine. And also it is an analytic function. So what is the meaning of that? F is a non-constant entire function. Fine. And yes, whenever f is a non-constant, remember it's a non-constant, by using the again the Picards, f is my unbounded. Fine. So what is the meaning of the unbounded? There exists a sequence. So what is the unbounded? This is a bounded. This is unbounded. This is the convergent, bounded, cancel out. So there is an unbounded of this. So sequence is unbounded. So this option is here is a bounded. So there exists unbounded which satisfied a property. Okay. Now look at one more tips. Whenever you have the function of this nature, a plus b, z of, okay, I can simply take z of k. Fine. Whenever you have the function of this nature, then it means f of z, whatever the k, fine, whenever is of the form here, then f of a is a polynomial of degree greatest integer of this k. Fine. Now if you compare this function, now it's a modular sign. So what is the f of this? I can say this number is less than of a plus b times modulus of k. Fine. Now if you compare this, a is my 0. In this case, a and b both are my greater than 0. Fine. K must be greater than or equal to 0. Whenever this property hold, then f is a polynomial of degree greatest integer. If you compare them, a will be greater than or equal to 0. B in this case is a k, and k is my greater than 0, and this is my here. So what is that? If you compare them, it must be a polynomial of degree greatest integer 1, that is 1. So what is the meaning of that? Can you find a polynomial of degree 1, say a? What is the value of a? You can see f of 1 is my iota. So what is the meaning of that? F of 1 is iota. So a is my iota. So what is the function of this? Is my iota z. So what is the value of the f of iota? Is my minus 1 is the right answer. Fine. That's a very simple. You can easily solve it by using this concept. Look at one more example. F of 0 is 0. F of 0 is 1. 2, f of dash is my 2. Find of, okay, again a very simple. If I assume az plus b, f of 0 is my 1. So what is the meaning of that? B is my 1. Fine. F of 1 is my 2. It means a plus b is my here. So a will be my 1. So function will be my z plus 1. But it is not satisfied here. What does it mean? It is not a linear function. Fine. So it means I can assume a non-linear function. Can you think about here? Clearly say 0 is a 1, 1 is my 2. So I can simply say it's a non-linear function as here. Otherwise, you can simply choose a square plus b plus c. F of 0 is 1. That means c is equal to 1. F of 1 is my 2. A plus b plus c. So that means a plus b should be 1. F dash of 0 is my 2. That means 2a, that's a b is equal to, what is the derivative of this? 2az. So that's my 2az plus b at the point z is 0 is my 2. So b is my 2. Once b is my 2, a will be my minus 1. So my function will be minus z square plus 2z plus of 1. So can you satisfy 0 is a 1, 1 will be my 2. That's a function of this. Now find the second derivative. Second derivative will be my minus of 2z plus 2. Find the modulus value. It will be less than of 2 times modulus plus 2. What is that? It is not. Can you find for all those z in the C? How you can find the value of the z? Okay, can you say this number is less than of? How you can say this number is less than of this? How you can find that? Okay, you are unable to find through here because the domain of z is not given. Okay, I can assume this function because through here, can I say what is the first derivative of this is 2z, but it is not. Sorry, f dash 0 is 0. I wrongly written here. F dash 0 is my 0. So it means b is my 0. If b is 0, a is my 1. So this is not there. Now, what is the second derivative? It's a 2. Fine. So if I substitute here, so what is this? It means I can find a bounded function of this. So what is the f of 2? F of 2, 4 plus 1 is 5. 5 is my right answer. I wrongly written here is a, so this is my 2. So this is my function, and therefore which satisfied this property because it's a bounded function. So what is the f of 2? Is a 4 plus 1 is 5 is the right answer. So this is a way you can solve this Schwarz Lemma inequality in a simple manner. We will see the next lecture on the function of several variables. Till then, you can simply like, share and comment on video. Happy learning all.